Hi Professor Chen, this is my second video for your third assignment, and this video is about question 2. And first, let me introduce this question first. X is uniform in the range between a to b, and the y equal to the square of x, which describes the relationship between the variable x and variable y. And the first question is find and draw the fyy, which is the probability density function of y, and the distribution function of x, which is fxx, like here. And we can tell from this question that the x is uniform in the range between a to b, so x is a uniform distribution, so we can just easily to write the probability density function of x, which is like this. The fx equal to 0 when x less than a, and fxx equal to this one, the 1 divided by the b minus a when x located on the range between a to b, and when x greater than b, the fx is still 0. And we can integral the probability density function, so we can find the distribution function here, the fxx. When x less than a, the fxx equal to 0, and when x located on the range between a to b, it would be like this. And if x greater than b, fxx would be 1. And with these two different functions, we can simply draw the diagram about these. So the first one is the probability density function of x, and the second one is the distribution function of x, like this. And the second part of the first question is find the probability density function of fyy of y, which is fyy, like this. We already know the relationship between the variable y and x, and we can just simply apply this formula here to find the probability density function of y. But we don't know what exactly a and b is, so we need to discuss several different possible circumstances here. And the first is when a and b both less than 0, so there is only one possible circumstance here to make sure that fyy not equal to 0, which is the negative square root of y located on the range between the a to b. We can get the y located in the range between the square of b and the square of a. Then the negative square root of y is the only root here, so we can apply this formula, and the gx, which is the relationship between the variable y and the variable x here, so we can get the fyy like this. And otherwise, there's no root located in the range between the a to b, so the fyy equal to 0. And the second circumstance here is when a less than 0 and b are greater than 0. And this circumstance can be divided into two different sub-circumstances here. The first is when absolute value a is less than absolute value b. So when y located in the range between the square of b and square of a, there is only one root here. There is only one root here located in the range between the a to b, so we can get so by applying this formula here and the relationship between the x, y, we can get this. And the second is when y located in the range between the 0 and the square of b, because we already know that y equal to the square of x, so y must greater or equal to 0. So when y located in the range between the 0 and the square of b, the both of its root, the negative square root of y and the positive square root of y, located the range between the a to b, so we can find the probability density function of this part is like this. And otherwise, there is no root in the range between the a to b, so the fyy equal to 0. And likewise, we can discuss the second sub-circumstance here when absolute value of a less than absolute value of b, so we can get this. And likewise, we can discuss the final circumstance here when a and b both greater than a. So like the first circumstance here, we can find the probability density function like this. And according to these four different circumstances, the probability density function of these four different circumstances, we can simply draw the diagram of these like this. These are four different probability density function of y here. And the second question is, now given that a equal to -1 and b equal to 3, find and draw the fyy, which is probability density function of y, and the distribution function of y, and find the expected value of y here. And we know that a is equal to -1, which is less than 0, and b equal to 3, which is greater than 0, and the absolute value of a equal to 1, which is less than absolute value of b, which is 3. So the condition offered by this question satisfy the third circumstance here. So we can just let the a equal to -1 and b equal to 3. So we can simply find the probability density function here like this, and we just integral this function, so we can get the probability, the distribution function is like this, and we can draw the diagram according to these two different functions. And expected value of y, we can just simply apply the definition of the expected value of a continuous random variable here like this. We need to use y multiply its corresponding probability density function and integral this from the negative infinity to the positive infinity here, so we can get the answer. The expected value of y is like this. And that's all. Thank you.